So, hello everyone. Nice to see you all here. The guy on the big screen looked familiar, so I guess I'm in the right room. If you're interested in learning more about different tools and libraries in Java, basically have a sneak peek at a lot of different tools, then you're also in the right room, because that's what I'm going to do in the next 15 minutes. So I won't deep dive into any tool. I will just give a brief overview so that you're aware that different tools exist. And whenever you're like, hey, I want to learn more about that one, yeah, look it up on YouTube, watch the website of the project, and then see if you can maybe use it in your project at work. In my normal work, I'm an architect at ASML. Who knows what ASML does? A few hands, okay. Most people aren't familiar with it, but we actually create the machines that all major chip manufacturers use to create the memory, CPU, and everything in your smartphone and in your laptop. So that's what I do in my daily life, but I also like to share my knowledge, and that's why I created this session. If you later have any questions, feel free to approach me here or on one of the social media. Basically, I cover different topics in this session. So tools, I split them up in these 5 categories, and we'll go over them one by one, basically. If you want to look at the examples, I created a GitHub repository. I see it's just below the translation. So if you go to my GitHub, so /Johan Janssen, you can find it quite easily. So here I have about 60, 70 examples of tools and libraries. I won't be able to cover all of them, so if you think this is interesting, feel free to have a look later at these examples and try them out. You can just clone the repository and run the examples that you want. So here the list is shown of the different examples that I have. But let's simply get started with the first one, and that's about architecture. And the first one I'm going to show is ArcUnit. And with ArcUnit, I can basically specify architecture rules as unit tests. So let's have a look at some of them. So for example, I can create a rule where I say that all the classes in the controller package, which have the address controller annotation of Spring, should have a name that ends on controller. And that I automatically assert. Of course, I mean, I have one class that I wrongly named, so I will get a failure in this unit test. So if I want to fix this issue, I should rename the wrongly named class to wrongly named controller, and I'm good again. I adhere to the architecture. So this is a very simple example still. What we can also do is say how different layers of the application should use the other layers. Let's say that traditionally we have that view layer and controller layer, service layer, database access layer, and we don't want to have like the view layer directly accessing the database layer. We can specify rules for that. So let's have a look at this one. So first we begin with all the classes inside the payment package should only depend on classes in either common or in one of the frameworks that I'm using. So I cannot use something from like the user package or some other package to make sure that I have the right flow of dependency inside my classes and packages. So here you see another example. So the common one, it can only depend on common stuff or on framework stuff. So it cannot depend on the payment or something else. And if I don't do that, I get exceptions like the one here. So you get quite clear exceptions if you don't adhere to the rule. And because this is like a unit test, it's run with every build, basically. It's not super slow or something, so you can just run it automatically to control your architecture. And then you can do it even more advanced, so we can define layers. So I can say, okay, I have a controller layer, and that's basically all the classes inside the controller package. And the same goes for the service one, which has the classes in the service package. And then I can add those constraints again, so the controller layer cannot be accessed by any layer, because nowadays everyone has like a JavaScript front end, which will then access the controller layer. And the service layer can only be accessed by the controller layer. So this way we can again make sure that we follow some architecture principles. And if we don't do that again, we get quite clear errors on what goes wrong, and we can fix that. Because often it's not even that we willingly do something different than the architecture, but we're just trying out something. We try to fix something, and then accidentally we might use classes that we shouldn't use from that place. So this is a nice automated way of trying to prevent that. Then we go to a bit more test-related tools and libraries, and the first is awaitility. So in the past, what often happened if you have like asynchronous tests, so here we have some asynchronous code, really simple, basically it sleeps for 1 second, and then it adds something to a list. So to check if this happens, I can do that assert equals, but if I do that immediately, that 1 second here isn't completed yet. So then I can add that thread sleep of 2 seconds to make sure that the asynchronous action has been completed. Oh, I don't want that. Go away. And then I can check again if this happened. The problem of this example is that it always takes 2 seconds or more than 2 seconds to complete this. And if you have either a faster laptop or a faster build server, you sometimes get issues because you put it too low on one of those systems, and you have tests failing because of flakiness, which is super annoying. So instead of that, we can use awaitility. So instead of doing a thread sleep, I can say, OK, await at most 2 seconds until that example list.size is equal to 1, and then I can do checks again. So this automatically runs, basically, and then if we run the entire class, you can easily see the difference. So we see the first one takes more than 2 seconds, the other one a bit more than 1 second. So it's a bit faster and also a bit nicer to program this way instead of having all those thread.sleeps in your test code. Then we go to another tool, the Jfokus agent. Who here is familiar with Jfokus? I think a lot of people are using it to measure the coverage of your unit tests or maybe your integration tests. But who's familiar with the Jfokus agent? Not a lot of people, and that's what I commonly see. The Jfokus agent is something you can attach to your Java process, and it can measure any coverage. So if I'm doing monkey testing and I just click around in my application, or if I have like a performance test, or if I run my cucumber tests or other acceptance tests, I can measure the coverage that's being generated with anything that happens, basically. And it's relatively easy. And one example where we used it for in the past, we had acceptance tests, and often people say, yeah, you shouldn't relate that to coverage because testing pyramid and everything. But we thought we had quite a good coverage of the functionality with our acceptance tests in Cucumber, and we wanted to check if that was actually the case. So we measured the coverage of those tests, and we found out we actually missed quite some of the code. Quite some of the code wasn't covered. And when we dove deeper into it, we found out it was actually dead code. It wasn't used anywhere. So it has quite some good use cases where you can use this for. So let's have a look how it works. Scroll too far down. So I put in a small README in case you want to do this yourself. So what we basically do is we start the Java process. In this case, it's a simple application. So this jar file is being started. And at the same time, I provide that Jfokus agent. And I say it should not append stuff. And it should include the classes com.example.star. If you don't do this filtering, it will measure the coverage for all the code. So also for Spring or other frameworks and for the Java code. So probably you don't want that. You get a huge file of coverage then. And that Jfokus agent, this one, that jar file that you provide, you can just download it on the Jfokus website. So it's relatively easy to get. So let's run this one. So I run this. Now I have a relatively simple application up and running. So let's access that one. I think it was Scar. So now I access a simple REST endpoint that's small, but doesn't really matter for the example. So I went to the application. Now what's important is you need to stop the application. So I specify that the coverage should be recorded, but the coverage is only written once I stop the application. When I tried this myself, I was completely puzzled because that file stayed empty all the time. Then I went to grab a coffee and stop the application, and when I came back, of course, the file was filled. So don't make the same mistake as I did. Just stop your application. And then it writes it in some binary format, so you probably don't want that. So to create a nice HTML report, we can use the Jfokus CLI Also, you can download it at the same place as the agent from the website. Then it creates a nice HTML report. Let's have a look at that one. This one. So now this, yeah, you maybe are familiar with these reports from JFrog, or maybe you integrated them in SonarQube or something like that. But this is basically the coverage that's being measured. And you can see here I only accessed the get endpoint, so that one is nice and green. And I didn't use any post stuff or call the exit endpoint, so that part is red. So I can measure any coverage that I want this way. And then we go to another testing-related tool, and that's PyTest. PyTest is a form of mutation testing. And what basically happens is, if you have the normal like production code, so code like this, I created a really simple example with some if-else statements. Then your unit test is run, and after that, some mutations are created of your code, so of your production code. So what it will do, it will, for example, replace this bigger than sign with a smaller than sign. And it will create different versions of your code. Could be like 8 versions of the code for each unit test, and it will run all those 8 versions of the code again. So it will run that unit test 8 times for the different code. And if the unit test is still passing, then basically your unit test isn't good enough because the code can be changed and the unit test doesn't fail. So that's basically what it's doing. And this greatly helps you to create better unit tests. It's like a quality check for your unit test. For example, if you forget to assert some statement, or if you refactored code and you added some if-else constructions, and you forget to test that properly, PyTest will automatically warn you for it. So this is a nice way to automate the improvement of your unit tests. Of course, because it creates mutants of your code and runs the test again, it could be that it runs all your tests 8 times. So it can take a bit of a while to run this. So maybe you want to run this in like a nightly build and not on each commit. So I created one test, a really simple one. It asserts that in this case, the answer is 42, so probably, yeah, you can guess that I didn't cover all the branches. And then what I can do is I can easily run the Maven PyTest stuff with this command, or automate it in some of the Maven phases. And then I get a HTML report. I will just immediately show the report. That's just as easy. So here, if I click through, I see, okay, some parts are red, some parts are green again. So green is good, of course, and red is not so good. I can see what happened. So for example, it replaced the int return with 0. So instead of returning the highest value here, it returns 0. And the test still passes. So then I have a survived mutant, and that's something I need to fix. You can also see which mutators it uses, so which changes it is making, and you can also customize this if you want, but I mostly use the default set. So this way you can improve the test code that you write for your application. So next one. Test containers. Who's using Docker nowadays? A lot of people, right? It's so popular using containers. It really makes life easy. With test containers, basically what you can do is you can automatically run stuff in a Docker container and test against it. And that stuff can be anything. It can be a database, could be something like Kafka or other messaging services or streaming services. So anything you have in a container. Big advantage, of course, is that in this example, that my SQL container, it will just spin up. If I run it on my laptop, it will spin up in the build server. I don't need to install MySQL somewhere and make it accessible for everyone. I just spin up the container. So for some types of containers, they already have this predefined class that you can use. Otherwise, you can just use the generic class and use whatever Docker image that you want to use. And I created a really simple example with relatively plain stuff where I retrieve the URL and username and password. I connect to the database and I store some stuff. So it's relatively straightforward. I didn't want to mix in other frameworks in it, but yeah, this automatically spins up my container, runs the test against it, and shuts down the container again. So this is really helpful and used a lot nowadays. Yeah, it takes a little bit of time, but you probably believe me that it works, right? And we have more cool stuff to show, so let's continue in the meantime. So I am actually going to demo a few tools at the same time. You can use them independently if you want, but I mean, to save some time, I mixed all of them at the same time in one example. I again have more or less the same car application with, I should show this one, it's a bit more interesting, with some REST endpoint that returns just some arbitrary information, not super interesting. And then I use Gatling basically to do performance test. Maybe you did performance test in the past with JMeter. I did it as well. Don't really like it. It's quite a lot of work to get some nice reports for your manager out of it, because it basically outputs plain data, and then it's up to you to use Excel and create nice graphs and stuff. And yes, some things in JMeter I didn't really like. That's why I started investigating Gatling. And in the past, Gatling only had a Scala DSL. It was still relatively easy to use because you didn't really need to know Scala, but nowadays it's even easier. They have a plain Java DSL which you can use. And basically you write your performance test in plain code. So here I specify the URL, and then I create a scenario. So in this scenario, I basically have a loop that loops 5 times. I first access the car endpoint. I check that the response that I get back is a 200, so that it's basically OK. I pause, I access the other endpoint, and again check if I get a 200 back. Then at the bottom, I use this ramp users. So basically what happens is, if I start my test at 0 seconds, I have 0 users. Then after about 5 seconds, I have 4 users, and after 10 seconds, I have 8 users. So the number of users is built up gradually. There are different ways that you can do this. You can also start them at once. It's all possible. So this is all I need, basically. A really small file where I specify what I want to do. So let's start this application. And at the same time, what I will also show you is mission control. Anyone here used mission control? Few hands. So if maybe you did profiling in the past, maybe with Visual VM or other tools. If you ever have to do that, or if you're interested in this, I can really recommend mission control. In the past, it was included in the JDK. Now you need to download it separately with the newer versions of Java, but it's freely available. Where in the past you needed to pay Oracle as well if you ran it on production. Now you can use it everywhere for free, and it has really low overhead. So depending on how much checks you enable, it only has like 1% overhead. So you could even use this on production to profile your application. It's really built into the JDK basically, so it's really cool tool. And to do that, I have my car application here that I started. I can basically connect to it and say, okay, I want to start a flight recording, and I quickly need to go here to make sure that I also set up my, not that one, my tests, because else I need to be really quickly later. So this one, yeah, you can specify what you want. I just use the default settings, 1 minute, with everything enabled basically. So it's a bit slower than, it has a bit more overhead, but it's local, so I don't care that much. So this is running for 1 minute, so now I need to start. I think it was Gatling test. Let's double check in the meantime. Yep. So like mentioned, you can use these tools separately. You can use Flight Recorder separately, or Gatling, whatever you prefer, or combine them like I did. So here you can see that my test is getting started. Basic simulation is started. I see how much users are active, how many are waiting. I see if my requests are OK or not OK. See a bit of progress. Yeah, this goes really quick. So then it's done. And we can look again in the target folder for the reports. I ran it again also this morning, so I have 2 reports already, but both should be more or less the same. So if you're used to JMeter, yeah, you know it's quite a bit of hassle to get that plain text data into some nice graphs. This is generated automatically by Gatling, basically. A nice graph. It shows which requests went OK. So for car, they all were OK. For car parts, also they were all OK. I can see things like 99 percentile, which is often used within companies to determine what the performance of the application is. I can see the number of users that are active across that time span. Response times, number of requests per second, basically a lot of statistics, and you even can get more details if you look at the detail one. You see more stuff here as well. You can see it per endpoint that was being tested, basically. So there are a lot of information that you get for free out of the box when you use this. And next to that, we also had mission control running. So this is what mission control created. They give some high overview already, so you see a couple of topics here. So if you click, for example, on heap, it automatically analyzes and says, okay, most of the heap was used by only a few classes. Yeah, that's correct. I mean, I have a really simple application, so there's not much interesting going on there. But I can see really a lot of details. So for example, I can see which methods take most of the time in the application, so that way I can try to improve the performance of those methods. I can see which exceptions occurred. I can see when garbage collections occurred. All kinds of information about the garbage collection. So if you want to tune your garbage collector or try out different garbage collectors and see how they work under the hood, you can get a lot of information from this one. So there's a lot available. Also, which exceptions occurred in the meantime, yeah, threads, memory management, everything you can see here. So really, if you want to do some profiling, go and have a look. Then I go to some other ones, like equals verifier, which is more for implementation. Anyone wrote their own equals method in the past? A few people. Do you think it was correct? Because I also did a try. So I created this student class, and I created an equals method, and I was like, yeah, it looks quite okay, right? Do some checks. I compare if the different fields are equal, and yeah, should be sort of okay, I think. But then when I tested it, actually, so with equals verifier, I can test each class if the equals method is implemented properly. And it's not properly because I get this. Found a problem in class, hash code should be equal, okay. A bit cryptic, but if you dive in a little bit, you can actually find the solutions. And I came up with a fixed student, so I needed to add final to all the fields. And you see here, I have a bit more checks in here as well. So if I run the test again against this fixed class, it doesn't throw any exceptions. So this way you can easily check for all your equals methods if they are okay or not. And then we go to GraphQL. GraphQL is like SQL, but then for your REST endpoints. So let's say you have a REST endpoint that returns a lot of information. I've seen REST endpoints that return like a megabyte of information, but on some pages, you only need the one name in that 1 megabyte, which is a bit of a shame because you get all the 1 megabyte over the line to your customer and only use a little bit. With GraphQL, you can basically say what you want to have from that REST endpoint. So in my example, I specified a schema, so I have an account, and an account has a user. So those are both Java classes. You can also see them here, account and the user. And I specified a query here, but the most interesting part is in the test here. Let's have a look. So what I do here is I do a query for the account, and I query for the ID and the number. So then, when I do that GraphQL, I use the GraphQL tester to execute the query against my REST endpoint. I can see that I got my ID back and my number back, because that's what I specified here. When I try to retrieve the user, it's not there, because I didn't ask for it. Then if I specify my user in my query a little bit different, so here I say I want the ID, I want the number, and for the user I want the first and the last name. Now if I query again, I get that information back. So this way you can ask your endpoint what information you basically want. Of course, the disadvantages is that your controller is often a bit more complicated, so you need to do some query mapping and schema mapping stuff. So it's a bit more difficult to set up than a normal REST endpoint, but it gives you a lot of flexibility in cases where you desire that. Then, who of you has been approached by a recruiter in the last month? No one? Are you that bad? So I'm actually going to show you how recruiters work. So maybe after today you're like, I'm fed up with all this Java stuff, I become a recruiter myself. So you can specify templates. It's plain HTML with some like special stuff in it. So here you can see, okay, hello, first name, last name, some function title, a list. So all these things will be replaced in the Java code. And for that, I use handlebars. And it looks like this. So I have some generic stuff, and then I say, okay, I want to add a person. I want to add some expertise. Yeah, nowadays, I mean, everyone needs 20 years of GraalVM experience, right? PHP, of course, I mean, also relevant if you do Java. J2EE, still some recruiters think that's hip. And of course, I mean, you need a really cool title, right? So I came up with a really nice one. So if we run this, I basically just output it in the console. You could also output it to a file or anything. And then what you get is basically everything nicely filled in. And now you know why they often forget your first name. They simply forgot to put it in. So yeah, it's a really nice job, 55 hours per week, days off, I mean, no one cares, right? And you get a really good salary. So this is how you could do templates. Of course, it's a joke that you can do it as a recruiter only. You can also use this if you send emails to customers or something like that. A lot of systems, they send emails with HTML, which you need to customize. And of course, you could do that in plain Java, but it's a bit ugly. With this, you can easily template it and replace the fields that you want to use. So I use handlebars. There is also Pebble templates, which is even more advanced than this. You can use different files for your templating and everything. So if you want to have even more advanced stuff, have a look at that one as well. I also included an example for that one. Then we go to Java Poet, which I think is one of the better names for a library, right? It already sounds cool. So what you can do with Java Poet is you can actually create Java classes. So let's say we want to create this class. Again, it's a student class with some simple fields, constructor, and stuff. So I can create that class this way. Make it a bit bigger. I can create a setter. I can create a getter. All this code is for that. Then I can create the constructor. I can create the class, and then the file. And I can actually create this. So if I run it, I have that class. So before you return to your job and rewrite your entire code base like this, probably your colleagues won't really like it. But this is used a lot in libraries and tools where dynamically classes need to be constructed. So then this is really helpful. So if you ever write like a library that's being used within different projects in your company and you need to generate classes automatically, then really have a look at this one. Then the next one is Job Runner. So we probably all have seen applications where you want to run some stuff at a certain interval and things like that. So for example, here I have a recurring job. I can specify the cron expression. Here I also have a job, and I say, OK, if it fails, I want to automatically retry it. So this add job annotation and add recurring, that's basically from Job Runner. Not do that. And if I run the test for this, and in the meantime, quickly go to this one before it's finished. There's also a nice dashboard for it, so you can actually see which things you have scheduled. So here I see I have some jobs, some recurring jobs, some servers. So I see a recurring job. I see something that's being printed. So this happens every 15 seconds, this every minute. I can see what's being enqueued, what's succeeded, what's failed. So a lot of information about the jobs can be found this way. It's a really nice one, and in the test, I actually have a few more examples. So here I also schedule some jobs, like every 15 seconds or at certain time intervals. This one that's being automatically retried because it fails, I throw an exception, it tries it again. So this way you can do a lot of things with jobs, like if you want to do like database backups or whatever job you want to do, it's a really nice tool for that. And then another one where I quite like the name, JSoup. So with JSoup, what you can basically do is you can connect to the internet or even locally, and you can parse HTML documents. So let's say you want to retrieve something from an HTML document. In my case, I maintained some Chocolatey packages to install Java on Windows. And there is a page online where it says how many downloads there are. And of course, something needs to fail during a demo, so we have that here. Apparently, some security was changed. But normally, yeah, you can use this. You can see here how I go through, use some CSS tags to basically find the location inside the HTML page, and then I can loop over the elements that are being returned and find the information that I have. If I would have created the page myself, I could have, of course, used a CSS tag already on the information that I needed, but here it wasn't the page that I created, so I looped until I found whatever I needed. Then there is a tool where I always doubt if I should show it to you guys, because I actually am afraid that's going to work against me. You know these websites where they ask for your phone number. You don't want to give it, right? Because then people start calling you for sales stuff and other stuff that you don't like. So often you can fill in a fake phone number, right? You just fill in whatever, and it's approved. With lib phone number, you can actually check if someone supplied a valid phone number. So in this case, I have this local number from the Netherlands where I'm from, and I can parse this number, and I can check if it's a valid number. And this is like a landline number. You know, in the past, you had phones in your home with a cable and everything. So for those, you can even see from which city they are, but you cannot get the carrier. Then if you have like a mobile number, so in the Netherlands they start with 06, I can see from which country they are and from which carrier they are. So this way I can get quite some information, but the most important one probably is the is valid. And it doesn't matter how I specify it. So if I use the 00 and then the country code or the plus sign or without it, it will automatically parse it. And yeah, this one is too short. It needs to be 10 digits, so this will fill. So this way you can check if your users are actually supplying a valid number. Then it could still be a number from somebody else, of course, but at least it's a valid one. Then we go to a tool called MicroStream. Basically, I guess most of you are familiar with it. You have that relational data stored somewhere, and you need to create a mapping. So often we use ORM frameworks like JPA, Hibernate, those kind of tools. With MicroStream, basically, you directly program against objects, which makes it a bit easier to program. So in my case, I have a relatively simple example again, where I want to store stuff. So I create a car, and I can basically say, okay, storage manager set root Porsche, which is this one. I can store the root, and then it's basically stored in my database without having to create mappings to tables, to different rows and columns and stuff like that. So it works quite automatically. And if you use Spring Boot, it's even easier. You can use those repository constructs of Spring Boot and say, okay, remove everything, and then add the different objects that I want to use. And in the end, basically, you can retrieve everything again with the find all. So this seamlessly integrates with Spring Boot if you want to use it. And then we come to another tool. And nowadays, every talk needs to have something about AI and cool stuff, right? So this is, I think, the closest to AI you'll see in this session. It's basically a tool to solve any scheduling issues. So let's have a look at one example. So, and let's have a look at the rules, because they are actually, oh, there was already something running. I should have stopped that first. Let's run this one again. And in the meantime, discuss the rules. So basically, it solves stuff based on some constraints that you give, some rules. So what I did is basically I did conference scheduling. Like for a conference like JNation, you have a lot of sessions, you have a lot of speakers. Some speakers might do 2 slots or 2 sessions. So you need to make sure that everything is nicely scheduled according to whatever you want. So I have a few rules. For example, that each room can only have 1 session at a time, because it would be a bit weird if another speaker would present next to me on a different topic, right? Then we have a speaker conflict, because yeah, most speakers, they cannot give 2 sessions at the same time, so you also want to make sure that the speaker only has 1 session at the same time. So that's all in these few lines of Java code. You basically specify these rules. Then if a speaker has multiple sessions, he or she prefers to stay in the same room, because then you're used to the audio, to setting up everything, etc. So if a speaker has multiple sessions, I mean, yeah, he's really happy, of course, because he has those sessions accepted, but we want to punish the speaker a bit for that and make sure that all the sessions are back-to-back to make him work hard for his money. And then we have language stability. So let's say here, I think here all the sessions are in English, but let's say some sessions would be in Portuguese and some would be in English. Then you might want to do all the Portuguese sessions in a certain room and all the English sessions in another room. So these are the constraints that we have. Now let's look at how that looks like. So I have a bunch of a bunch of rooms basically here at the top. These are the rooms, these are the slots. And I have a lot of unassigned lessons. So these are all the sessions that I want to plan. Then I click on Solve. It takes a little bit. And then it planned everything. And then I was a little bit puzzled, like, why are there two sessions at the same time? Anyone an ID? Because I said that it shouldn't do that, right? Anyone an ID how this goes wrong? Basically, I cheated the system. I have more sessions than I can plan. And so it's my own problem. You still, with the rules, need to think carefully that you don't break the system. So here you can see I have two constraints, two hard constraints that I couldn't fulfill. So I couldn't find an optimal plan. And then I saw that was actually planned by myself, so that was quite easy to explain. But then I saw another one. I have Sander Mak, a former colleague who does great sessions, so I gave him a few sessions. So there's one here, I think there's even one here. So he has 3 sessions. And I said that each session would be back-to-back, right, if it was by the same speaker. But then I noticed that here, there are actually other sessions in between. And at first I didn't understand that, so I looked a bit closer to the rules that I implemented. And then I found out that I actually specify that if a session is within half an hour of another session, then it should be back-to-back. But actually between these, there was a longer break. Let's see, yeah, here there is like a break from 12:15 to 2 o'clock. So basically, yeah, again, I messed up the rules. It's my fault that it planned it this way. So it helps a great deal, but make sure that your rules are correct, because, yeah, it's basically garbage in, garbage out. So make sure you do it correct. And then we go to Spark. So Apache Spark is often used for big data processing, or if you have algorithms that take a long time. Because with Spark, what you can actually do is you parallelize the work. So you distribute the work across 10 physical machines, 15 physical machines, whatever you want. And then it automatically parallelizes it for you. So I created an example. I have a data set from Amazon. I think it was 28 gigabytes, 29 gigabytes even. And it has all the reviews of Amazon for, I don't know, 10 years or something for all their products. And I searched through all of them to find stuff which is Java related. So I searched stuff with the text Java programming language. So I can run this. It takes a little bit of time. I think it's 1 or 2 minutes, but it actually does everything automatically. So it uses all my cores. It maximizes my computer. I run everything locally. Normally, you would distribute it across multiple machines, of course. But it is able to process these big-sized data with, yeah, only a few lines of code, basically. I tried to rewrite this in plain Java, and then, of course, you first need to find out how you, again, read a file, because you never use that. And once I got it up and running, of course, after I don't know how much time, I got that out-of-memory exception, because it's 29 gigabytes big, and my memory is only, 32 gigabytes, and it crossed the memory heap. So Spark takes care of that automatically. So even if you want to do something on a single machine, it could be actually easy to do it with Spark. Maybe it's then not the best performance, but it's relatively easy to set up. Yeah, this takes a bit of time, so let's simply continue with the next one. And we'll go to the security-related ones. We'll start with the OWASP dependency check. So with OWASP dependency check, what actually happens is you download huge reports from the internet, and those reports basically then are used to check your dependencies if they have any vulnerabilities. Let's simply show an example that probably explains it better. So I configured it basically in the Maven configuration. If you use Grail, you can, of course, also configure it. And then I can easily run it with Maven Verify. In the meantime, my Spark also finished, so it took probably about two minutes. So now, normally it will go to the internet. It will download the latest reports if they are not up to date yet. I made a local copy so that I don't need the internet for that, but that's more for presentation reasons. Normally, you should, of course, make sure you have an up-to-date version. And then it prints a HTML report, or creates an HTML report, but it also prints the exceptions that you have. So I have an exception here for log4j. I don't know, maybe you heard of it. Apparently, there was an issue with it. So that's really easy to use. And then we have another one, POSI. This one I didn't know, someone else came with this one. But it's actually, if you want to test if someone provided a valid new password, you often have some rules, right? Like some uppercase, some lowercase, some weird characters. And you can try to create a regular expression for it, but yeah, I'm too stupid for regular expressions, so I need something else. With this, I can basically just define some normal human-readable rules. And then what I can do if someone adds a new password, I can say, OK, validator, validate. Yeah, this, of course, is too simple password. So I get some really nice responses as well. So it should contain 2 or more uppercase characters, blah, blah, blah. And then I can create a bit more difficult one. It still complains because there is 1, 2, 3 in it, and that's not allowed. Then I create an even more difficult one, or actually 2, and I can check that those are valid. So if you ever need to validate passwords, have a look at this one. It's really convenient. And then we'll go to another way to manage your dependencies, and then not checking if there are any issues, but checking if there are new versions of your dependencies. So for example, to make sure your Spring Boot is up to date, or one of the other tools, frameworks, and libraries that you use is up to date. Because you can do that manually, but it's often forgotten. So it would be easier if it was automated. And there are tools available that do that automatically for you, like Dependabot, or you can use Renovate or other tools. And they basically create pull requests automatically. So if I look at my pull requests, I already merged all of them. For example, here I have a pull request to update the PDF box, and this is generated automatically. So I basically run a job once. You can run it like once a week, or you can trigger it manually, whatever you want. And it creates a pull request basically with the updated version in it. And then I only need to say, OK, accept that pull request, maybe even automatically run a build on that pull request to make sure your code doesn't fail, and then you're good to go. And then we have another one, which is called Open Rewrite. Who's already on the latest version of Java? No one, right? But let's say you want to go there, because I hope everyone goes to a new version of Java soon. You can do that manually and fix every compile issue that you find. Or you can see if you can do that automatic. So with Open Rewrite, it provides a set of recipes, basically, to automatically update your code. So it could be from one Java version to the other. It could also be from one framework to the other, so from Spring Boot to Quarkus, or vice versa. So there are a lot of recipes already available that you can use. You can also write your own ones if you want to. And that way you can basically upgrade or change your application. So how does that look like? Let's go to it. I configured a little bit of stuff in the POM, and then I run a command that does the upgrade. And the nice thing is, it doesn't only upgrade my dependencies, it also improves the code. So if you upgrade to the newer version of Java with multi-line strings, it will automatically transform your ugly traditional strings to multi-line strings. So it improves your code base, actually, as we will also see in this example that's now running to upgrade. So I do an upgrade now from JUnit 4 to JUnit 5, also something that you could do manually, but it would be nicer if you just automate it. So it already gives some messages, but I can also simply use get diff. And then I can see what basically was changed. So of course, my dependencies are changed. The old one is removed. I get a new one. But it also fixed my formatting. So here I have some spaces or a tab. I'm not sure, but it removed it. Here as well. So I have something that's possibly null, and I compare it to some string. It automatically turns it around because this is more null safe, of course. So it makes a lot of changes in your code base that are really helpful. And because it's, so here it uses new constructs of JUnit. Also the new exception handling is being used, as you can see here. And it's all, it's basically Git stuff. So if you don't like it, yeah, you ignore it or you remove it again. But at least it gives you a starting point in your upgrade of migration to another tool, basically. And then let's go to another tool. Okay, it doesn't want to stop. How many of you are using Maven here? Quite a few, I guess, right? So normally when you do Maven, you can do like Maven compile, right? Oh. You can grab a drink. And I'm not even running tests. I mean, that would be even worse. I could get another drink. Yeah, and then you're waiting, right? Almost done. Yeah. Now I could do this. I could do Maven daemon compile. First time it will be a bit slow because it's starting a daemon. It looks a bit like the Gradle daemon if you use plain Gradle. So first run is still taking a little bit of time, but it was already, I think, faster. Let's make it a bit bigger. Where is it? It doesn't show the total time this time, or let's simply run it again. So now it's 1 second. So yeah, you can either do this next week for your project as well, or don't tell your colleagues, because it will mean you get less time to drink coffee and chat, right? And there are actually some more improvements now with Maven. You also have Maven cache extensions, which you can also add to your project. If you need to make use of a bit recent Maven version to allow that. But with Maven cache extensions, it's caching stuff, and that also greatly improves the build time of your application. So yeah, really, if you want to increase your build time, use either the Maven daemon or the cache extensions. The Maven daemon, basically the only thing I did is install the Maven daemon. I don't need to change any POM configuration for it or Maven configuration. It works out of the box. So with that, I think we are nearing the end of the talk. So are there any questions, last questions, before we go for lunch? I won't keep you too long. Yeah, just shout. If I understood it good, but it's really far away, if you use timefold, can you later adjust the schedule that's being made? Yeah, I think that's possible. I didn't try it myself, but from what I heard is that for example, Devoxx Belgium, they use timefold to create like a first version and then make some changes to it later, yeah. But yeah, the alternative would be that if you run it first and it's not completely like you want it to be, you could add an extra rule to make sure it produces what you want. But sometimes it can be tricky to have the good rules. Yeah. Okay, then thank you all very much and have a good lunch.